Section 2.3, modeling real-world data with matrices. We're going to start by defining what a matrix is. Matrices is plural of matrix. Matrix is a singular one, and we're not talking the Keanu Reeves movies, where he bends over backwards and slows down time and avoids bullets. Not that kind of matrix. A mathematical matrix, is just a rectangular arrangement of numbers. It's basically a box with numbers in it. Those numbers that are inside that matrix are called elements. Okay, it's the individual entry or number in a matrix. And then when we talk about the dimensions of a matrix, we're always written rows by columns. And like I said here, it's read rows by columns. So it'll be a 3 by 2 matrix, or a 1 by 5, or a 6 by 2, or 7 by 3, something like that, where it's always read rows by columns. So let me give you a couple of examples of what just matrices look like. A 2 by 2 matrix, 2 by 2 matrix looks something like this. It's just a box. The brackets do not make a whole box. It's not, we're not going to put the whole thing all the way across. It doesn't work that way. It's just the brackets around the edges. A 2 by 2 matrix could look something like this. You could have a 3 there, 10, -6, and 0. That's what a 2 by 2 matrix is. We could have a 1 by 3 matrix. Ooh, that's not very good writing. 1 by 3 matrix might look like this. So we have one row with 3 columns in it. One row, something like 7, -1, and 4. That would be a 1 by 3 because we have one row and 3 columns. It's not how many are in the row. This is not a 3 by 1 matrix. A 3 by 1 would look the other way around. It would be a 1, 2, 3. It'd be a vertical one, where this one's horizontal. And then the last example I've got here for you would be a 4 by 3 matrix. 4 by 3 matrix. This one's a little bigger, but it's still just a matrix. We have 4 rows, so we could have, let's say 17, 11, 0, and -9 would be the first entry in each row, and then we could have -3, 1, 2, and 8, and then 13, -5, -12, and 1. That would be an example of a 4 by 3 matrix. So it's just a rectangular, just a box of numbers, basically. Boxes can be any size, whether it's tall, short, long, it doesn't really matter. Just it's a rectangular arrangement of numbers. So I got a couple of examples here for you. First one, we're just going to make a matrix. This one's kind of a longer setup. During the summer, Miss Robbins received several types of grain to feed her livestock. She received 15,000 bushels of corn, 2,000 bushels of beans, and 500 bushels of oats in June. In July, she got 13,500 corn, 6,500 beans, and 1,000 oats. And then for August, she received 14,000 corn, 550 beans, and 1,500 oats. Display the data in a matrix. Now, you've got 2 different ways that you can do this. We have 3 different types of grains. We have 3 different months. So we're going to have a 3 by 3 matrix. So I'm just going to leave space here for a 3 by 3 matrix. And we got some bigger numbers, so leave yourself plenty of room here. You've got 2 different options. You can either do the months along the side, or you can do the months on the top, and then if you do the months on the side, then you do the grains on the top. If you do the months on the top, then you do the grains on the side. It really doesn't matter. The way I did it in my notes, I did the months on the side. So we have June here, and then we'll have July, and we'll have August, and then we'll have corn, beans, and oats. So the setup tells us everything we need to know. So if we're talking June, we got 15,000 bushels of corn. So we'll have 15,000 bushels of corn. We got 2,000 bushels of beans. So 2,000 goes there, and 500 bushels of oats. So 500 goes there. And then we do the same thing for July. So July, I'll do that in blue here. July, she received 13,500 of corn, 6,500 of beans, and 1,000 of oats. And then I'll do the August in green. Let's see, 14,000 corn, so 14,000, and then 550 beans, 550, and for August, for oats, 1,500. Okay, so there's our matrix right there. That's all we need to do. Sometimes matrices have labels, like this one does. Sometimes they don't, like these don't. Either one is fine. If it represents a specific characteristic, it might not be a bad idea to label them, but you don't necessarily have to. Okay, matrices are equal when the dimensions are the same and all the elements are identical. Okay, so this example says find the values of x and y for which the matrix equation is true. So we're going to assume that these two are equal matrices. We have a 2 by 1 matrix here, and we have a 2 by 1 matrix here, so the dimensions are the same, and this tells me that the elements are equal. The corresponding elements are exactly the same. So what we can say here is that y is equal to 2x minus 6, and we can say that x is equal to 2y. What this becomes is simply a two-variable system of equations, which we talked about in section 1. I'm going to use substitution to solve this. I'm going to take this 2y, since x is equal to 2y, I'm going to put that right there in that equation. So we can say that y is equal to 2 times, there's x, so that's now 2y. Still have minus 6, and we're going to solve for y. Okay, so we'll say y is equal to 4y minus 6. I've got y's on both sides. I need to get them to the same side, so I'm going to move that to the left. So negative 3y equals negative 6, and then we just need to divide by negative 3, and we're going to find that our y value is 2. Once we find our y value, so there's half our answer, we're going to take this and I'm going to put it right back in there. We can say that x is equal to 2 times my y value, which is now 2, and then 2 times 2, that's pretty easy, that's 4. So there are our two answers. X is equal to 4, y is equal to 2. We don't necessarily need to write it in ordered pair because it's not an original system. We're looking for what x and y are equal to for this matrix equation. I got a second one here for you. If you want to pause the video and do it yourself, feel free. For the purpose of saving time, I'm not going to do all the work here. I'm just going to write the answer. So if you want to pause it and then look, feel free. In this one, x is equal to 2, and then y is equal to 8. So again, if you want to go back and do this one on your own, feel free. Don't have to, but those are the answers. Okay, we can do regular operations, add, subtract, multiply with matrices. We're going to start with adding and subtracting. When we're adding and subtracting, the key here is the dimensions have to be identical. Okay, if they're not identical, it's not possible. So if you get something where you have a 3 by 2, so let me go to pen. If I gave you something like 1, 0, 0, 1, 1, 0 plus 0, 1, the dimensions here are not the same. So if you get something like this, then your answer is real easy. It's just not possible. And there's your answer. But with this one, we have a 2 by 3 plus a 2 by 3. So we can add these two together. And when we do this, we just add or subtract corresponding elements. So it's really, really simple. It's just a matter of combining things in the very end. So we're going to have another 2 by 3 matrix. So we're going to have negative 2 plus negative 6 for our first element, and then we'll have 0 plus 4 down below it, and then we'll have 0 plus 7 as we move across, and then 5 plus negative 3, okay, and then 1 plus negative 1, and negative 8 plus 10, and all we need to do is add those two together, or add those numbers together. Negative 2 plus negative 6 is negative 8, 0 plus 4 is 4, 0 plus 7 is 7, 5 plus negative 3 is 2, 1 plus negative 1 is 0, and negative 8 plus 10 is 2. And there is your final answer, the one here I'm going to put in the lovely little cloud. Now, you don't have to show this step all the time, especially when we're adding and subtracting. I can trust, or I'm going to assume that you know how to do negative 2 plus negative 6 to get negative 8, and so on down the line. So I'm not going to focus hardly at all on writing this step out, but definitely I want you to be able to write the answer. Okay, number 2 here, and I'm at the bottom of my page. I'm not going to spend a whole lot of time writing this extra stuff down here. I'm just going to write my answer off to the side. This time we're subtracting, so just make sure you keep your signs organized. Again, the dimensions are identical. We have a 2 by 3 and another 2 by 3, so we're good there. We just need to subtract from left to right. The first one, negative 5 minus 2, is going to be negative 7, and then as we go down, 7 minus negative 4 is 11. And going back to row 1, row 1, column 2, negative 4 minus negative 1 is going to be negative 3. And then moving down, negative 8 minus negative 2 is negative 6. And then we need to fill in our third column, 1 minus 3. That's going to give us negative 2. And the last one, 4 minus negative 8. Double negative again, that's going to be positive 12. And there is our difference, or our combined matrix when we subtract those two. We can do two types of multiplication with matrices. The first one I'm going to show you is really easy. It's scalar multiplication of matrices. Essentially, I think of this as the distributive property of matrices. A scalar is a vocabulary term. It's just a number a matrix is multiplied by. So in this example here, I've got matrix A. It's a 3 by 3 matrix, and I want you to find 4A. So really what this means is we're going to say that 4A is equal to 4 times our original matrix, negative 4, 3, negative 3, 1, 7, 1, negative 1, 0, and 8. And what we're going to do is we're going to basically distribute this 4 into all 9 of these elements. Okay, so we're going to take 4 times negative 4, and 4 times 1, and 4 times negative 1, and 4 times 3, and 4 times 7, and times 0, and negative 3, and 1, and 8. And that's going to give us our product. That's going to give our new matrix. I'm not going to write out the step. I do have another step in my notes where I actually show negative 4 times 4, and 1 times 4, and negative 1 times 4. I'm going to go ahead and skip that just to save some room on my sheet here. So we're just going to go ahead and distribute this. So 4 times negative 4 is going to give us negative 16. I'm just going to go down here. 4 times 3 is 12. 4 times negative 3 is negative 12. Move to the next column. 4 times 1 is 4. 4 times 7 is 28. 4 times 1 again is 4. 4 times negative 1 is negative 4. So now we're in column 3. 4 times 0 is still 0. And 4 times 8 is 32. And that's all there is for scalar multiplication. It's really, really simple. It's just a matter of taking the number out front times whatever the original matrix was. We can also multiply matrices together. Now, this is the complicated part of this section. This is going to be what we focus on for the remainder of this video. And I've got a few examples here for you, so this might take a few minutes. But just hang in there with me. It's kind of hard to explain. It's a lot easier to show, and hopefully you can kind of pick up on the pattern. So, matrix multiplication. The order in which you multiply matters. Okay, so if we said matrix A times matrix B, we have to keep it in that order. Matrix A times matrix B is different than if we went matrix B times matrix A. Okay, so keep that in mind. So let's just say that matrix A is an M by N matrix. We don't know the dimensions, but we know it's M by N. It could be any two numbers. It doesn't really matter. Okay, and then matrix B is an N by R matrix. Okay, so we're multiplying here. M by N times N by R. Now, when we're multiplying matrices, these have to be the same. The inner two numbers must match. Okay, so this number and this number have to be the same. If they do not, then you cannot multiply them. Then your answer is just not possible, or the book might write impossible. If the inner two numbers do not match, then you cannot multiply the matrices together. The numbers on the outside, okay, these are going to be your new dimensions. New dimensions, okay? This one and that one give you your new dimensions. So if we did an M by N times an N by R, what we would get in return, so let me go back to blue, is an M by R matrix. Okay, now to find each element in the product matrix, we're going to multiply each element from the row of the first matrix by the corresponding element from the column of the second matrix, then add the products together. So that is a mess to write. It probably doesn't mean a whole lot, and it's really hard to find words and how to multiply matrices together. I'm going to show you a couple of examples here. Hopefully you can pick up on the pattern. Okay, so use matrices A, B, and C to find each product. You can see A, B, C right there. A is a 3 by 3, B is a 2 by 2, and C is a 2 by 3 matrix. Example number 1 here wants us to multiply matrix B times matrix C. Okay, so it tells us the order in which it wants us to multiply. So let's first figure out if it's even possible to multiply these two matrices together. So matrix B is a 2 by 2 matrix. Matrix C is we have 1, 2 columns and 1, 2, 3 rows. So this is a 2 by 3 matrix. I shouldn't have done that. Let me get rid of all those extra lines up there. So this is 2 by 3. So what we need to do is we need to compare the inside two numbers. These match, so we are good. We can multiply these together. And the two numbers on the outside then tell us our new dimension. So this is going to result in a 2 by 3 matrix. So it's going to look a lot like this one. The numbers are going to be different, but it's going to have this same shape. It's got 2 rows. It's got 3 columns. So when I think of a 2 by 3 matrix, here's what I think of. I think of 6 entries, and I kind of label the entries. Like we've got row 1, column 1. This would be row 2, column 1. And then we have row 1, column 2. This would be row 1, column 3. This is row 2, column 2, and this is row 2, column 3. So these are kind of how I identify what my product matrix looks like. And this kind of helps me figure out what row and what column from the original matrices, these, that I need to multiply together. So I'm going to be kind of shifting back and forth here. I'm going to be sliding up and down. So just kind of bear with me. Hopefully you don't get motion sickness. But let's just try to figure out what we're going to do here. Okay. So for row 1, column 1, what we're going to do is we're going to take row 1 from matrix B times column 1 from matrix C, and we're going to take the first entry times the first entry. Okay, so we're going to take first entry 4 in row 1 times the first entry in column 1, which is also a 1. And then we're going to add, and we're just going to keep going. As we move to the right, we're going to move down. Okay, so we're going to take 2, which is the second entry in column 1, or row 1, times 3, which is the second entry in column 1, and we're going to add those together. So 4 times 1 is 4, 2 times 3 is 6. So my first entry in my product matrix is going to be 10. The first element, the first row, first column in my product is going to be 10. Okay, so we're going to keep going back and forth. We need to figure out all of these 6 entries. We've already got the first one. Now we need to go find the next 2. So I'm going to switch colors here, do this in orange. So it really doesn't matter. I'm going to go row 1, column 2. So now I'm looking for that one right there. So row 1, we're going to stay in row 1, and now we're going to move to column 2 in my product matrix, or in my, I guess, in matrix C. So row 1, these two numbers, the 4 and the 2, are actually going to stay exactly the same, because as we move to the right, we're going to move down. So the only numbers that change here for column 2 are going to be the numbers from column 2 in matrix C, which are these right here. So it's going to be a 2 is the first element, and then a 1 was the second one. So we're going to multiply again. 4 times 2 is 8. 2 times 1 is 2, and what do you know? We get another 10. That doesn't always happen, but it might. It's just going to be kind of the luck of the draw. Now we need to find row 1, column 3. So we'll switch to brown. So row 1, column 3. Again, since we're using row 1, these numbers on the outside, this is still row 1 from the product matrix, so that's not going to change. These are going to stay 4, and then a 2, and then we'll figure out what they're equal to. So now we're going to be in column 3 here. So we're going to have negative 3 for our first parenthesis, and then 0 for the second one. So negative 3 and then 0, because as we move to the right in our B, we're going to move down in our C. So 4 times negative 3, first element times first element, second element times second element. So there's how that's going to work. 4 times negative 3 is negative 12. 2 times 0 is 0, so that's really easy. That's negative 12. Okay, so now we've got the first row. We've got these 3 done. Now we need to find the next 3. So switch to red here. So now we're going to do row 2, column 1. So row 2, now we're going to be in this row of matrix B, and then we're going to go back to column 1 of matrix C. So my first entry in matrix B, row 2, was negative 2. And then my first entry in column 1 of matrix C, so now we're going to be there and there, so it's negative 2 times 1, plus, let's see, move to the right and move down, so it's going to be a 3 and a 3. So we're going to have a 3 from matrix B, a 3 from matrix C. We'll multiply here. This is negative 2, this is 9. That will give us 7. I'm going to switch to blue now, so now we're going to do row 2, column 2. Whoops. So now we're going to have row 2, column 2. So negative 2 and 3 are going to be the same two numbers. 3 plus parenthesis, parenthesis. Let's see, column 2, we got the first one was a 2, the second one was a 1, 2 and a 1. So that's going to be negative 4 plus 3. That's going to be a negative 1. Okay, and then we'll do the last one in green. This is row 2, column 3. Again, we're going to use these same two numbers, so I'm not going to scroll back up. Negative 2, parenthesis, plus 3, parenthesis, equals. All right, column 3, that's this one. So we're going to have a negative 3 in the first one, and then a 0 in the second one. Negative 3 and a 0. Negative 2 times negative 3 is positive 6. This is a 0, so that will give us a 6. So in our final answer, we can write this out now. So we got a 2 by 3 matrix. We did these in rows, so we're going to have a 10, and then another 10, and then negative 12, and then row 2 was 7, negative 1, and 6. And there's our final answer, okay? There is our product matrix. That's all there is to it. Let's try another one here. We're going to multiply A and B, or A times B. So, switch to red here. We got matrix A. Matrix A, if we remember from the last slide, and you should have it on your notes as well, matrix A was a 3 by 3. Matrix B is a 2 by 2 matrix, and what we need to check is we need to check these middle two numbers, and in this case they do not match. If they do not match, then your answer is really simple. It is not possible. There is no way for us to multiply these two matrices together, so we can't do it. This is all we can write. We can say not possible, and that is it. So number 2 goes really, really fast. Number 3, let's try another one here. Let's try matrix A times matrix C. So we need to do this one more time. Matrix A, that was again a 3 by 3. We just had matrix A. Matrix C, let's see, matrix C, if we go back, was a 2 by 3. So let me go back there. This is 2 by 3. Again, we need to check those middle two numbers. Once again, we have a 3 and a 2. They are not the same. So if they're not the same, your answer here is not possible or impossible, whatever you want to write. And that's all there is to it. There's nothing else you can do with this other than write not possible. Now, I said the order in which you multiply matrices matters. So if AC is not possible, that doesn't mean that CA is also impossible. So if we look at number 4, if we do CA, we need to write this out and just see if this is going to work. So matrix C is a 2 by 3. Matrix A is a 3 by 3. And if we look at those middle numbers, now they're the same. Now they're the same. So if they're the same, we can actually multiply them. And then these outside two numbers, this tells us our dimension. This is going to give us a 2 by 3 matrix. So it's going to look an awful lot like this first one that we did. We're going to have a 2 by 3 matrix in the end, but now we're going to have to think about our numbers one more time. Okay, so this one's possible, so we're going to write this out. I'm going to just kind of write it out. Just give me the spacing. So 2 by 3 means 2 columns, 2 rows. So row 1, row 2, and then 3 columns. So row 1, column 1, row 1, column 2, row 1, column 3, and then we'll have row 2, column 1, row 2, column 2, and row 2, column 3. So we're going to have 6 entries to find, and we'll have to I'm going to be flipping back and forth here to get our numbers. So I'm going to start with row 1, column 1, and we're going to go matrix row 1 of matrix C times column 1 of matrix A. So if we go back, and we scroll back up here, so row 1 of column C, this time we're going this direction. You have to pardon all my colors. It's kind of hard to erase after you write it and write more things. We're just going to kind of stick with it. So row 1 of column C goes 1, 2, negative 3. So we're going to have 1 times something plus 2 times something plus negative 3 times something, and that'll give us our numbers. Now, the numbers that go in the parentheses, are the corresponding elements from the column 1 of matrix A. Okay, so matrix A is over this way. That's these. So we're going to have 4 and then 0 and then 3. So we'll have 4 and then 0 and then 3. And then we'll figure out what this is equal to. 1 times 4 is 4, 2 times 0 is 0, negative 3 times 3 is negative 9, 4 plus 0 plus negative 9, that's going to give us a negative 5. Okay, so we're just going to keep going down the row, or down across the row, down the column, doesn't really matter. I'm going to go row 1, column 2. If I'm using the same row here, these numbers outside the parentheses are going to stay exactly the same because we're still using row 1 of column or of matrix C. So it's still going to be 1, 2, negative 3. We're going to be adding, multiplying, adding, multiplying. Okay, and now we're going to use column 2 of matrix A. So column 2 of matrix A is this one. So we're going to go negative 1, positive 1, negative 2. We'll multiply again. 1 times negative 1 is negative 1. 2 times 1 is 2. Negative 3 times negative 2 is 6. Negative 1 plus 2 plus 6 gives you 7. And then we're going to keep going. Row 1, column 3. Since, again, we're using row 1, these numbers are going to stay. 1, 2, negative 3. And we're going to figure out column 3 now of matrix A. That's this one, 2, 0, 4. So that's what's going to go in the parentheses, 2, 0, 4. 1 times 2 is 2, 2 times 0 is 0, negative 3 times 4 is negative 12, and when we add those together, we're going to get negative 10. Now, we've got row 1 done, now we need to move to row 2. So I'm going to do row 2, column 1. So now row 2 of matrix C is these, so 3, 1, 0, so 3, 1, and 0. Then these numbers are going to be pretty easy. And then we're going to use column 1, column 1 of matrix A. So again, we're going back to column 1. So 4, 0, 3 goes in our parentheses. 4, 0, 3. 3 times 4 is 12. 1 times 0 is 0. 0 times 3 is also 0. This is going to give us a 12. Now we need to do row 2, column 2. So row 2, again, these numbers outside the parentheses are going to be the same because we're using row 2 of column C. So row 2 is going to be 3, and then a 1, and then a 0. And then we need to use column 2 of matrix A. I keep going the wrong direction. That's this column right here, negative 1, 1, negative 2. So negative 1, 1, negative 2. 3 times negative 1 is negative 3. 1 times 1 is 1. 0 times negative 2 is 0. This will give us a negative 2 when we add them all together. And then the last entry, row 2, column 3. Again, row 2, the 3's, the 1, and the 0 stay the same. Column 3 of matrix A is this one right here. So 204 goes in our parentheses. 204. And we'll just move them down the line. 3 times 2 is 6. 1 times 0 is 0. 0 times 4 is also 0, so that's a 6 as well. And then we can write our final matrix when we're done here. I'll just do this right up above the original. We'll have negative 5, 7, negative 10, and then 12, negative 2, and 6. And there is your product matrix.